Amorphous solids do not have a definite, regular, internal shape. Now you may have heard of crystalline solids. Well, the main difference between crystalline solids and amorphous solids is that amorphous solids, like I said, do not have a definite, regular, internal shape. So this gives amorphous solids three interesting qualities. So the first is, when amorphous solids cool into a rigid form, they retain fluid-like properties. Now, because these amorphous solids have no definite, regular, internal shape, they can be easily molded. And so think about glass, for example. That's an example of an amorphous solid. And glass comes in a variety of forms and shapes. It can be a glass bottle, or it can be in a window, or it could be some kind of complex glass structure. The point is, glass can be molded into many different shapes and sizes. And there's other types of amorphous solids as well, like rubber, for example, which can be molded into automobile tires, or sheets, or gaskets. And there's also plastics, which can be molded into all types of shapes and sizes. So that's an example of how amorphous solids can be molded. Now, the third interesting characteristic of these solids is they do not break into regular crystals. And so remember how I was talking about glass as an example. You think about if you dropped a glass bottle, the different pieces of glass would not all be the same size. You would have some little pieces, some big pieces, and some in-between pieces. And again, that's just for example, because amorphous solids do not break into regular crystals. Now, if you think about crystalline solids, they do break into regular crystals. So again, there's another difference between amorphous solids and crystalline solids. But the main thing you need to remember is that amorphous solids have no definite, regular, internal shape.